Okay, the next rule that we're going to talk about is called the quotient rule. And generally, whenever you think about quotient, you think about division. Okay, so this rule deals with what are we going to do if we divide exponential expressions. Okay, so an example would be like x to the fifth over x to the third. So this means x to the fifth divided by x to the third. A lot of times we'll write division as a fraction. So this actually means that x to the fifth would be x times itself 5 times over x cubed would be x times itself 3 times. Okay, well common sense says if we wanted to divide this out, then I would say x into x would go one time, x into x would go one time, x into x would go one time. Okay, well what would be left over? We would have 1 times 1 times 1 times x, so that would just be 1x squared. We wouldn't have to write the 1 that would be understood to be in front. But the part I want you to see is where would this come from? Okay, there's only 2x's left over, but again, what if this were x to the 50th over x to the 30th? We wouldn't want to write out 50x's and 30x's. Okay, but you can kind of use this as a visual in your mind, to think about what would really happen. The quotient rule tells us that if we're going to divide variables, then we're going to subtract the exponents of the like variables. Okay, so we've had 3 rules so far. The first one was the product rule, which told us to add the exponents. Second one was the power rule, which tells you to multiply. And now the third one, quotient rule, tells you to subtract the exponents of the like variables. Okay, so let's look at a few examples. If I have y to the 7th over y to the 3rd, okay, I can only subtract when it's the exact same variable. Okay, so just picture this. If I had 7 y's out here and 3 y's on the bottom, what would it simplify to be? Well, there would be y to the 4th left over because I would subtract 7 minus the 3 gives me the 4, but I keep the variable. Now, if I have something like x to the 5th over y to the 3rd, well, these are different variables. That's as far as I could go with this. I could not subtract those, okay? They have to be like variables. Okay, this even could work for numbers. You could have something like 5 to the 8th over 5 to the 6th. Well, it's the same base, still, both 5's. So I could subtract, and this would be 5 to the 2nd, which of course then I would simplify to just be 25. And I realize now that I just called that B, and that should have been C. Oh well. Okay, D would be if we have more than one variable. Okay, if I have x to the 8th and y to the 6th over x, y to the 5th. Okay, again, I'm just looking at my like variables. So if I have x to the 8th over x to the understood 1, if you want to write that in, if I subtract 1 from 8, I'm going to get x to the 7th. Okay, and then with my y's, 6 minus 5 would give me y to the 1st. Don't write your 1 here. I don't think it'll mark it off on the computer when you type in your answer. But just to be safe, don't write the 1. It would just be x to the 7th y. Okay, if we have let's say 9a to the 4th, b to the 7th, and that's over 3 b to the 2nd. Okay, this time we have coefficients that are in front of your variable. So this still means division. Okay, this means 9 divided by 3. So I would have to divide that out and say 3 will go into 9 3 times. Okay, so that leaves me with the 3. Then I look at my variables. A to the fourth over a to the first is going to give me a to the third. B to the seventh over b to the second is going to give me b to the fifth. So then my answer would just be 3, a to the third, b to the fifth. Okay, pay attention, or just let's look back over these few examples for just a minute. Where was the higher exponent? When I go back and look at a up here, y to the seventh over y to the third, the higher exponent was in the numerator. And so when I subtract, it's like my answer goes to the numerator. It's y to the fourth because that's where it would be left over. Okay, same thing on D. This is a good one to look at. X to the eighth over x to the first. The higher number was on top, so that just gave me x to the seventh. Okay, the reason I'm pointing this out is because of something we're going to look at in section 3.2, which is negative exponents. Okay, right now they're all positive, but I just wanted to point that out to you. Okay, one more example that I want to show you deals with this last rule that I have here that's called the zero power rule. It says anything raised to the zero power is 1. Okay, well let's look at why that's true. If I have x to the fourth over x to the fourth, what is the quotient rule going to tell me to do? Subtract the exponents. Okay, so if I subtract and it's x to the 4 minus 4, which is what we're doing in our head, it would be x to the 0. Okay, it wouldn't be a 1, but actually x to the 0, and you would have to write the 0 because if there's no exponent that we see, we understand it to be a 1. So if it needs to be a 0, you've got to write the 0. Okay, so we get x to the 0. Well, what have we been taught since the very beginning of fractions? What if I have the same thing over itself? I have x to the fourth over x to the fourth. We say anything over itself is 1. Okay, so for that reason, we say that this is equal to 1. If you have something raised to the 0 power, it will always be 1 because you can relate it back to a fraction where you have the same thing over itself. And we know in mathematics that that's always going to be a 1. So I can promise you on the test, there is a question that's probably going to look like this. 2x squared, y to the third, to the 0 power. Okay, as long as everything in that problem is to the 0 power, the answer is still 1. Okay, so I don't want you to miss that on the test. There will be a question about 0 power. Anything to the 0 power is 1. Now, there's a few kind of tricky problems that you might see. It may give you something like 5 to the 0 plus 6 to the 0. Okay, well, what is 5 to the 0? 5 to the 0 is 1 plus 6 to the 0 is 1. So my overall answer is 2. Okay, so don't let that confuse you a little bit. The other type that you may see could be where you have 5x to the 0. Okay, now this doesn't mean that the 5 is raised to the 0 power, but only the x. Okay, so this actually means 5 times 1 because x to the 0 is 1, and your answer would be 5. Okay, now look at the difference. If it were 5x all in parentheses to the 0 power, then your answer would just be 1. Okay, so go back and look over these examples, for a few minutes to think about. The individual term that's raised to the 0 power is always going to be a 1.